जय श्री राम दोस्तों. This is Manoj Kumar. Welcome you all on a new topic, optimizing C for ARM. We will discuss the several topics that are displayed on a screen. Firstly, we have the introduction part. Second, we have the understanding ARM architecture or optimizing technique, code optimizing, debugging technique, performance analyzing, real world application, and conclusion. Firstly, we have the introduction part. Welcome to the world of optimizing C for ARM microcontroller and embedded system. In today's presentation, we will explore the importance of optimizing C code for ARM architecture and how it is benefit for your project. With the increasing demand for the fastest and more efficient system, optimizing C code for ARM is becoming a necessary rather than an option. In this presentation, we will cover the various optimizing techniques, code optimizing tips, debugging techniques, and performance analyzing method for a C code in a ARM microcontroller and embedded system. We will also provide real-world example of a C code optimizing and highlighting its benefits. So sit back, relax, and get ready to dive into the executing world of optimizing C for ARM. Understanding the ARM architecture. ARM architecture is widely used to instruction set architecture, that is ISA, in a microcontroller and embedded system. It differs from the other architecture in several ways, including its received instruction set, computing risk, designing possibilities, and optimizing solutions and efficiencies. One of the key benefits of ARM architecture is its power efficiency. It is achieving through from the U1 pipeline, which also allow for a multiple instruction to be executed simultaneously and uses of a low power sleep mode. One of the key benefits of ARM architecture is power efficient. This is achievement through the uses of pipeline structure, which allow the multiple instructions to be executed simultaneously, and the use of low power sleep mode when a process is not in use. Additional ARM processes are highly customizable, also allowing to wide range application and performance level. Second slide, we have the optimizing techniques. One of the key optimizing techniques for a C code in ARM microcontroller embedded system is loop unrolling. This is involved in manually exploring loop of the reduce the number of instructions required to execute the loop. By reducing the number of instructions, we can improve the performance of our code. Another important techniques in function in learning the involve replacing a function cell with an actual code of function itself. This can reduce the overhead associated with a function cells, requiring the faster executing time. Next slide, we have the code optimizing. Code optimizing is crucial aspects of a developing software for ARM microcontroller and embedded system. It involves the identifying and removing efficiencies in a code to improve the performance and reduce resources uses. It involves identifying and removing efficient in a code to improve the performance of a reduced resources uses. One of the technique to loop unrolling, which is where generates multiple copies of a loop body, reduce the overhead loop control instruction. Another technique of a function lightning to improve the replacing of function cell called actual code of reducing overhead function called the instruction. To further optimizing code, it is important to minimize memory access and maximizing the use of register. This can be achieved by the using data structure that fit into the single register or cache line, such as bit field or a package structure. Additionally, choosing the right data types can also have the significant impact on a performance. For example, the UT8, instead of reduced memory, you can improve the code execution speed. In this slide, we have a debugging techniques. One of the most important aspects of a programming for ARM microcontroller and embedded system is debugging. Due to the complex nature of this system, it can be difficult to locate and fix error in a code. However, these are the several techniques that can make the processor easier. One such technique is using as a debugger to step through code and identify where error occurs. This allows developers to pinpoint the exact line of a code causing the issue and making necessary changes. Additional printf statement can be used to output value and debugging information to the console and terminal of an analysis. Next slide we have a performance analysis. When it comes to analyze the performance of a C code in ARM microcontroller embedded system, there are few key techniques that can be used. One common approach is to use profiling tools that can help identify bottleneck and arm where the code can be optimized. These tools can provide determined information on how much time is spent executing each functions, how many times each function is called, and how much memory is being used. Another important technique is used benchmarking, which involves running of a code on a specific hardware, perform the measuring its performance under difficult conditions. This can be help identify area where the code is partially slow or efficient and can also provide insight into how changes to the code affect in our performance. Next slide we have a real world application. One example of a C code optimizing in ARM microcontroller and embedded system is reducing unnecessary memory uses by minimizing the amount of a memory uses by a program. More memory becomes available for other tasks. This can be efficiently important in embedded system where resources are limited and every bit of memory count. Another real-world application of a C code optimizing is ARM microcontroller in embedded system in improving power efficiency by optimizing code to use the less power. Device can run longer on a single battery charge. This can be crucial in applications such as wearable or IoT devices that need to run for extended period of without being recharged. Next, we have come to the conclusion part of this slide or a video. In conclusion, optimizing of C for ARM in microcontroller and embedded system is crucial for achieving maximum performance and efficiency. By utilizing the various optimizing techniques and debugging strategy, developers can create code that runs faster, uses less memory, and consumes less power. The real-world example have shown the benefit of C code optimizing in ARM microcontroller and embedded system for improving battery life in IoT devices to increase the processing specific in our Optimotion application. Optimizing code can make a significant impact on our performance and functioning of these systems. Thank you for watching this video. This is Manoj Kumar 1B21CS09.